Hello everyone, good evening. I hope you're ready for our Ode aan the the 21st edition. Well, the program for today is as followed. Well, right now I'm wishing you all a good evening, and then we have our first talk with Aron Beurskens. He'll be talking about Kubernetes, and well, small intro for that one. A lot of development teams use Docker to develop their apps, and in this talk, Aron will explain how and why they get Docker containers up and running in production using Kubernetes. After the first talk, there's a small break, about 10 minutes, and then there's the second talk by Ewout Pieter den Ouden about PHPUnit. His talk is called Hall of Mirrors, and he'll be talking about how you can use PHPUnit to look under the hood of libraries and everything what's happening inside your app. Because, well, development teams often use multiple libraries, often with third parties and open source libraries. And while using PHPUnit, you can find out what's happening and why something is happening. Well, Aron, you're up. Go ahead.
Okay. Well, thank you, everybody. Nice to be here. Normally, I would say who is using Kubernetes in development? Raise your hands. But yeah, I can't see how many people are attending, and I can't see you. But well, this talk is about Kubernetes, and I'm going to tell you why I'm having this talk, because a lot of development teams want to use Kubernetes, often already use Docker for the development flows. But using Docker in development and in production seems to be a big gap for a lot of companies. And I'm trying to close this gap by giving this talk about Kubernetes and having giving some information. There might be a question about if I'm going to do this in English or Dutch. What is the preference? I assumed English because the intro was also in English, but if I need to switch to Dutch, it's also possible. So let's assume we use English for now. If I need to switch, I'll hear from you. So Kubernetes. A little background about myself. My name is Aron Beurskens. I'm the founder of NetEnse. NetEnse is a development company. We develop software, and from that company, CloudEnse arose. And CloudEnse is a managed hosting company. What we saw when we developed with our clients these great software projects, there was always a gap between development and hosting, and we learned our clients how to deploy pipelines, how to set up unit tests, how to set up test-driven development, and how to deploy it to the hosting environments. But most clients of us didn't want to do that. They just want to develop software. And from that, CloudEnse is founded. Well, these are my contact info. If you have any questions later on or tomorrow, feel free to mail or call me. I'm happy to help out with your Kubernetes questions. So CloudEnse does several things. We offer managed hosting. We offer managed Kubernetes clusters. Of course, you can just click on a button on Google and DigitalOcean and say, I want a Kubernetes cluster. But that's only the first step. Then you have this cluster running. But how do you deploy it to your cluster using continuous integration, continuous deployment? What are best practices? How do you manage the Kubernetes cluster? How do you limit pods? That are a lot of questions we get from clients or users who start the first time with Kubernetes, and CloudEnse is aimed at providing answers to those questions and giving support to the teams they already need it. Another about CloudEnse and myself, it's about this talk, it's about Kubernetes. So what are you going to learn in this talk? Well, it's basically transforming this picture, which is an AWS image of an application. You have some DNS with a load balancer, maybe some CDN with static resources. But the main thing is you have some virtual machines. And these virtual machines can be auto-scaling group, and they run a web application. And on this virtual machines, you might also have a database, maybe a high available setup with replication and some caches. It's basically a very common web development stack for PHP applications or whatsoever. This is the traditional way of hosting on VPSs, and this talk is about transforming all those servers and services and into Kubernetes. So, basic understanding of Kubernetes. I'm going to tell about Docker images and how to use it with Docker Compose to get them running. Our main tool is GitLab, so I'm going to show you how to use GitLab pipelines to build and deploy your Docker containers or your application structure into your Kubernetes cluster. And in the end, if I have some time left, I will have some fine-tuning tips on tricks on containers, project setups, and very fun stuff. So I'm going to keep this talk in a very high speed because most things are basic understanding and maybe boring. So I can skip to the demonstration part where I can show you things, which is a lot more fun. So what is this talk not about? It's not about setting up a Kubernetes cluster because that is a whole different subject. Administration of a Kubernetes cluster and monitoring of a Kubernetes cluster is out of scope of this project. We just assume there is a cluster, it's managed, it does its job, and you can deploy applications to it. So, the agenda. First, I'm going to give you a bit of theory about the Kubernetes core objects, what objects exist in Kubernetes. And that's only like 5 minutes, and then we start with really developing a containerized application, getting it running, and creating a GitLab pipeline to build the application. And hopefully it will deploy to a live environment. So the dull part, the theoretical part, Kubernetes objects. Kubernetes consists of objects. And with these objects, you can build your infrastructure. And you can refer an object as a persistent entity in the Kubernetes system. So Kubernetes uses all these entities, objects, to define what kind of environment you want to have, what kind of infrastructure you want to have. And a Kubernetes object is not an object itself, but it's more like a record of intent, which claims to the Kubernetes clusters, I want that the cluster runs this object somewhere. So by creating an object, I'm telling the Kubernetes system how the workload should look like. For instance, I want 3 web servers, I want a database, I want a Redis cache, and it's more like a desired state. Because if I remove one object, Kubernetes will spin it up again, because it will try to keep the system as it's defined in the first place. And the nice part about Kubernetes is that you can just provide these infrastructure in a YAML file. So no complicated things, just define a YAML file and it tells Kubernetes what do you want to run. So the first object within Kubernetes is a namespace, and the namespace is much like a namespace in development. It's a scope for names. So all the names under that scope can exist only once. And each Kubernetes resource can only be in one namespace at a time. And if I'm going to show you in a while, the command with kubectl is kubectl get namespaces, then it gives a list of all the namespaces which are present in the Kubernetes system. In this namespace, you can create pods. And a pod is a collocated group of containers. Mostly you will see that a pod will only contain one single container, but it doesn't have to be. You can define multiple containers in one pod, and the nice part about this pod is that it shares the IP address space and port namespace within the containers. So if I run two containers, one exposing port 80 and one exposing port 3306, I can use the local host on both ports and it will connect to it. Also, they share volumes. So I can map a persistent volume into a pod, and then both containers can read and write to that volume. If I'm going to tell Kubernetes to scale the pod, to upscale, for instance, I want 3 web servers instead of 1, it always scales the pod. It will not ever scale the containers itself. And you can get an overview of all the pods in the system with the kubectl get pods command. When you look at the image, you see our picture is growing. So we have a namespace, we have this web server pod, we have this database pod, and we have this caching pod. So these now theoretically exist in our Kubernetes system. But in order to let the pods communicate between each other, we need to create a service. And the service is a way to expose an application internally in the system. So by defining a service which connects to, for instance, all the web servers, it will always load balance the traffic between the web servers. The reason for this service is that because pods are mortal, so a pod can die because a worker crashes, and then Kubernetes will spin up a new pod. And this can be on a totally different worker with a totally different internal IP address. So connecting to a service will always make sure that it will eventually end up at the right pod. And a service targets the pods with a selector in Kubernetes. So the command for this is Kubernetes kubectl get service for all namespaces. Having services doesn't mean that a user from the internet can connect to it, because for that we need to create an ingress. And an ingress exposes the HTTP or HTTPS routes or any other route, any other port from the outside to the internal service. So a normal web connection on a domain on port 443 will go into the Kubernetes system, will find its way into the ingress. The ingress redirects it to a given service, and on the service it will redirect to a given pod. And an ingress is controlled by rules, where the most common is the domain name, which maps to some services inside the Kubernetes system. And again, kubectl get ingresses, all namespaces will show all the ingresses. There are 2 more objects which are important within Kubernetes. The first one is a replica set. A replica set is a stable set of pods. For instance, I can define a set of 3 web servers, and then Kubernetes will try to hold these 3 web servers in running. So if I delete one, it will spin up another one. But on top of as a shell around a replica set is a deployment. And a deployment declares updates for pods and replica set. And the deployment is used when I want to indicate in the Kubernetes system, change the number of workers from 3 to 5. And then it will, the number of pods. And then it will scale up the pods with 2 more. And the deployment will always deploy a set of pods in the system. 2 more side objects are jobs. A job is nothing more than a command, but within Kubernetes, running a job is like spinning up a pod. It executes the job and then it removes the pod again. So you can run a lot of jobs in parallel. If you have some heavy workload, you can define spin up 10 of these jobs, and then all the jobs will run, and then they will close, and your workload is done. So the main thing about remembering for a job is that it will spin up a pod, run the command, and then just destroy the pod again. If I want to do a job on a time-based schedule, like a cron job, Kubernetes has the same object, a cron job, which defines at what point in time a job should run. So exactly the same as a Linux cron job. If I define that a command should run every 5 minutes, in this case, Kubernetes will start a pod every 5 minutes, execute the job, and then destroy the pod again. So that was all the things I want to show you about Kubernetes. Let's dive into some demos and real-life examples. If there are any questions so far, let me know. I'm happy to answer them. So, is this readable? I hope so. If not, I can increase the size, but I can read it, and I normally wear glasses, but I hope you can read it as well. First step is creating a Docker application. So what I did is I have this demonstration project, which has a folder called app and a Docker compose file. Now, for people who are using Laravel, they can see it's a Laravel application and it has a Docker file. And this Docker file defines the server it's runnable on. So in this case, I defined a Docker file, which starts a PHP 7.2 application. I know it's been a while since I started this presentation, so it should be a lot higher at the moment. But it sets some Apache config, it does some updates, it installs some tools I need for Laravel, it installs some PHP extensions, it enables some Apache modules, it replaces the time zone, and it installs a composer in this case. And at the end, it copies just the folder of the app into the container itself, and then the application is ready. And my Docker compose file just indicates, hey, I have an app. The image is, in this case, a build context, which you can find in app Docker file. I showed you. Well, it has a name. It's a web server. And I define some variables because Laravel uses environmental variables. So it's my development environment, and I have this database, and this database username and password. And of course, I define in my Docker file that I have my SQL database, which needs to run, and I have this Redis container. So when I want to spin this up, I just say Docker compose up, and it goes bad. What is this? Line M. Well, PHP storm to the rescue. It's the same command. So I'm not sure why this goes bad. Oh, I'm in the wrong folder. So here you can now see I've run these 3 Docker containers, my app, my SQL, my Redis, it's running, and let's test it out. So Kubernetes Demo.localhost. Oh, it actually shows an application, Kubernetes Demo, and it's a Laravel application with just a view. I have some data which I'm going to use. This is the last time a job has been run. This is the last time a cron job has been run, and I'm using a cache store, in this case a Redis store. So you can actually see my Redis container is running and working. So let's prove that this is the actual application. I have this resources homepage. So hello Ode to the code, something like that. So yeah, this is actually the container I'm working on, and it's running, and this is my Docker container locally. I think until this point, a lot of you have done this so far. You use Docker hopefully in development. You build beautiful web applications using Docker. So hopefully this is no strange thing to you. So let's revert this. So I have this application running locally, but I want to get it in my Kubernetes cluster so people like you can access it. When I access the application at this point, I can only connect to it on the local host. So the first step is to show you how Kubernetes works with objects. I've shown you this kube control, and this kube control is now connected to my cluster. To do that, you just need to download the config file, put it in your home directory kube/config, and then you have connection to your Kubernetes cluster. And to prove it, I can use kube control get namespaces, and then it will show me a list of all the namespaces, and I can just show that I've created a namespace called Kubernetes Demo. I can just create a totally different namespace with kube control create namespace Ode to the code, right? And then it has this namespace Ode to the code. If I want to get more information about the namespace, I can use describe namespace and then Ode to the code, and then I will get some information about the namespace. And it has no resource quota or no limit range resource. So this namespace is allowed to consume all the CPU and memory power my cluster has on one worker. So if I want to get rid of the namespace, I just delete it. So kube control, delete namespace, Ode to the code, and then it's gone. So that's how you create namespaces. So the next step is to create a pod in check it out. Step 2, pod deployment. So when I want to check what pods are running in a namespace, I just say kube control namespace Kubernetes Demo get pods. So at this point, I have no pod running in the Kubernetes Demo namespace. I have told you that Kubernetes objects are defined with YAML files. So I've created a folder here and a YAML file, which is app deployment. And this is an example of a YAML file for a deployment pod. And it is a deployment, and it has a name called Kubernetes Demo. It wants one replica, so one replica pod, some more things. But the main important thing is it will pull an image, Kubernetes Demo master. It will have this demo URL, some password for the databases, which you should never use in your code, but this is an example. So you should put it in your GitLab secrets. But in this case, I can just apply it. So let's try to run it. Kube control, my namespace Kubernetes Demo, and then apply the file Kubernetes Objects app deployment. And then, okay, it has been created. Let's see if it's running. So if I get the pods now, I see a pod which has a name, Kubernetes Demo, with some hash behind it, and it is one of one pods running. So it's there, okay. But I've showed you in an example that only the pod is running, but I can't access it yet. For that, I need to create a service first. So a service is exactly the same as a deployment, but in this case a YAML file which describes the service. I want the service, which is called Kubernetes Demo service, and it exposes port 80 to the pods port 80, or it connects ports 80 to the pods port 80, and it does it by the selector of the Kubernetes Demo app. And the Kubernetes Demo app is exactly the same as the deployment here. So apply that. Apply it, and now I want the service to be applied. It's created, and I can show it by get services. There is my Kubernetes Demo service, and if I want some more information, I just describe the service and then the Kubernetes Demo service. There it is. So I now have a service with the IP address internally. It has a port 80 and it targets another IP address on port 80, and that's where my pod is running. So my service is running on a different worker, in this case, than my endpoint. But I still can't access it. So for that, I need to create an ingress. As you can remember, an ingress connects the outside to the inside of the Kubernetes system. So this is my ingress. I have an app ingress, kind ingress. It's of type Nginx. The nice thing about Kubernetes is you can define a lot of ingresses. You can use Nginx, Trafic, HA proxy, whatever you like. Just define it there. I like to use the Nginx ingress. So as I stated before, ingress is matched by rules. So I have this rule Kubernetes Demo.netends.nl. This is the host. Should connect to my service, Kubernetes Demo service, on port 80. Okay, let's apply this. Let's see what happens. Ingress. So my ingress is created. I want to see my ingresses. There it is. I have my Kubernetes Demo ingress on Kubernetes Demo.netends.nl, and I also can describe it. Ingress Kubernetes. There it is. So my Kubernetes Demo will listen on port 80, and it will show me my pod. It will connect to the service, and the service will connect to the pod. So let's try it. I have this HTTP Kubernetes Demo.netends.nl, and it's not secure, so Chrome doesn't like that. So let's try Firefox. Firefox isn't that strict. It also redirects. So let's not use a browser, just use Chrome. Right, so just to prove you, in this case, yes, it runs. I can see some HTML, which is my application. It's the Kubernetes demo. Welcome to the Kubernetes demo application. And it has the same job random string and some JavaScript. Don't worry, you'll get to see the application running in a second. So the next step, of course, is to add the SSL certificate. And I'm going to skip that because I'm going to combine it with another task, and that is connecting it to GitLab. Because every time using these commands to deploy your application into the Kubernetes cluster is not really desirable. What we want to do and want to achieve is that whenever I commit something and I push something to GitLab or any other thing like Jira, or of course you can't push to Jira to Bitbucket, or to Visual Studio team services, it will run some kind of job and then that job will deploy my Kubernetes, my pods to the Kubernetes system. So in that sense, we use Gitlab, and Gitlab has this project called Kubernetes Demo, and this is Reddit. Can go. So let's start with the next one, Gitlab. Step 6 at Gitlab. So how Gitlab works is it has this Gitlab YAML file, and this Gitlab YAML file defines the steps Gitlab needs to do before deploying it to Kubernetes. In this case, we use Docker. We have this image for our app, and what we define is then we have this stage called build, and when we commit, it should build the application by using Docker login. It logs into the GitLab registry because it needs a place to store the image. It builds the container, and then it pushes the image to the Docker registry. So that's, if I start this one and I just commit, then hopefully something happens here. You see I have this build running, and this build actually runs Gitlab Runner, and this Gitlab Runner will start and download the code. It will execute the Docker file, and it builds the Docker file. So let's review the steps once more. It's here. It will build. It will log in to Docker. It will build the app folder, which is here. It has this Docker file, and it pushes it to the Docker image. You can see it starts by downloading or doing all these steps in the Docker file. So installing, enabling PHP extensions. I'm going to stop this because this actually takes about 10 minutes. So the problem is when you want to deploy things into Kubernetes, or you want to deploy your code changes, you don't want to wait for 10 minutes. So what can you do to improve this speed? Well, this Docker file needs to update only once in a while. So when developing, I don't want to wait and rebuild the whole web server every time I commit something. So I'm going to split this up into multiple containers. So I'm going to check this out. And at this point, I have two folders. I have this app base and I have this app. And this app base contains the Docker file, which builds the basic web server. Just the thing, it takes about 10 minutes. And then I have this Laravel application with the same Docker file, but this downloads the base image from my registry, does some extra things, copying the files, run composer install, and this builds my app application. So when checking the GitLab file, I have now two stages. I have the build base image and I have the build. But the build base image, I'm only running this whenever I change the Docker file. So when I don't change this folder or anything in this folder, it won't execute. And it will only execute this part. So when I want to run this, start it, and push it. So far, splitting the applications. Next step. Let's see if it's building. There it is. So now it's building my application. and it's waiting for the runner to be ready. It's about 25 seconds. I think it will be about 1 minute until it completes. There it is. Its first step is to download the base image, which it has done. So download, download, download. Then it's going to install Composer packages. Now we can just see how this works. It is all been cached, so it's quite fast. There it is, and then it will. It has built the image, successfully built the image. It gives it a tag called step 7, and it pushes it to the registry. So at this point, I should have an image in my registry, and GitLab has this built-in container registry, and it's Kubernetes app, and then step 7, speed of build, published 32 seconds ago. So this is, of course, my latest image I've built and pushed into the registry. So that's step 1. Step 2 is deploying it to my Kubernetes cluster. When we check these files, you see all these variables. Kubernetes Demo, it has this URL, it has this database host, username and password. And the problem is, when having multiple environments, how does GitLab know where to deploy and what the database credentials are and what the URL is for the staging environment? And managing it with scripts is time consuming. So when we want to deploy a set of YAML files to Kubernetes system, I often use Helm, and Helm is like a package repository for Kubernetes. So Helm, and read more about it on this website, but Helm is like the package manager for Kubernetes, and it basically helps to manage Kubernetes applications. It helps you define, install, and upgrade even the most complex applications. Okay, sounds fancy, but how does that work? So the first step is, instead of creating YAML files, we are going to create Helm files. So this is step 10. Step 8, sorry. And we have this application, we have this base, and instead of Kubernetes Objects folder, I now have my chart folder. And my chart folder has a chart.yaml. And every Helm folder has this chart.yaml, which defines what this chart is about. So in this case, it's a chart for my Kubernetes application. And it has a set of templates. And these are the same as I've shown you before. It has a deployment, it has an ingress, and it has a service. But the nice thing about Helm charts is that they use variables. So I have this app name as a variable, as a value. I have an image which I can pass into my files. I have this host and this database host and this username and password. And I can just inject all these variables in these YAML files with Helm. And if I combine it with GitLab, I get the first, an extra step. So the first 2 steps were build the base image and build the normal image. And now the last step is deploy it to my Kubernetes. And the deploy step, it uses Helm. And it just defines that it wants to install Helm with a name of the folder chart. So all the YAML files, all in templates, are applied and executed in the Kubernetes system. And I can define some variables. So I can define the namespace, I can find a name, a version, an app name, and the app image. And this is the important part, because I'm injecting the app image into my Helm chart. So my app deployment values app image will contain that string. And my app image is now created with GitLab. So my app image is defined as a variable where it is my registry image. It's the registry of GitLab. And then my build ref name, which is basically my branch. And now it will instruct that it will deploy to my Kubernetes system the image of the branch I'm currently working on. Okay, so let's try it. So let's just commit and push and see what it does. I need to zoom Chrome a bit more. Like that. This is better, I think. Yes. Okay. I've committed. I see the step 8 deployment and it's running. So it's building my app. It's the first step. And then it starts the deployment. So we have to wait until this to finish. Well, it's now 38 seconds. So within like 1 minute, I have my changes built, and then it deploys it to Kubernetes. So let's go back. My build is done. My deploy is there. So we need to wait. Oh, that's fast. So there it is. So it upgrades all these charts. The release has been upgraded. It has been deployed. It's revision number 5. I did some updates, of course, before this presentation to test it out. And I can just check it out in my Kubernetes system. So let's see if I have an ingress. Yes, I have an ingress. So that's great. Do I have some service? Yes, I have 2 services in this case, the demo app. Do I have some pods? I also have some pods. So basically, at this point, I should run this on HTTPS. There it is. So also the provisioning of the SSL certificate has been managed by Let's Encrypt in this case, which is defined in my Ingress YAML file, because I have this cert manager, and this cert manager will issue a Let's Encrypt certificate for my Ingress. So let's go back. There's my Kubernetes Demo application built and online. Instead of using this kube control terminal, I mostly prefer a graphical user interface. And in this case, we use Rancher. And Rancher has a workload, created a workload. I can remove this one because it's the one on port 80. It's not something I want to use, so I'm just deleting this part. So these are applied. And I can just click it. It's much easier. So it will show a lot of nice things. So, you can also see how much resources are used in your Kubernetes system. So that's why we use this graphical interface. But this is the Kubernetes Demo application. So I have, at this point, 1 pod running of the Kubernetes Demo application. Assume I want to run multiple images. Then I can scale the pods. And scaling is done on the employment part, and in this case by the replicas directive. So I can define in my GitLab YAML file that I want to have 3 replicas instead of 1. Oh, I need some change. So in this case, just commit it. And then we'll wait until it has deployed this this pod. App starts another build, and it will scale my pods. While we are waiting for this, I'm going to show you one more thing, and this is called Helm Dependencies, because I now defined a set of templates which describe my ecosystem for my application, the Kubernetes Demo application. But a lot of maintainers of normal, most used daemons like Redis or MySQL also maintain a chart file for their application. So when I want to use a Redis server, I could create a Docker file which installs Redis, which installs Ubuntu, which installs a lot of other packages and Redis, and then exposes the Redis port to the outside. But there are maintainers for Redis itself, so it's much easier to use those chart files. So in this case, I can define a dependency, which is called a requirement, and it just defines, I have this dependency in my application, which is called Redis, and I want to use it. So it's downloaded on this repository of the chart from Bitnami, and it has an alias called Redis, and this will download a folder with all the YAML files which are needed for Redis, and then just spins up a Redis instance. So let's see if it's ready. Yes, it has been built, it has been deployed, and when I look at Rancher, you see it now has 3 pods running, so 3 dots of this Kubernetes Demo application. One more thing is the jobs and the cron jobs. So jobs and cron jobs. Because my Kubernetes Demo application has a job random string, so it's a string of the last random job of the last job, and it has this cron job. In order to define the job, I create a job YAML file which defines an image to pull and the command to run, and in this case it's an artisan command which updates the last job run, and the job is run after a deployment. So when I deploy a Helm chart, it will run once. So this is a great place to run your migrations for Laravel, or to do one-time things like cache clearing. If I want a job to be scheduled at an interval, I define a cron job, which is a schedule of every 5 minutes. It also pulls an image and runs a command, in this case the same command as the update last run. So if I deploy this, hopefully it will run my job. So push it. So sorry, I go back to the comments. Question. Configuration through YAML files requires knowledge about all possibilities. Would configuration with XSD schemes be better? Well, I only create YAML files for my own application, because mostly I just use the charts which are defined publicly. So I just use Helm and then pass in some variables and then deploy it. XSD schemes I haven't been using. I found my way around the YAML files. There are a lot of examples online. So I really don't want to say XSD schemes are better or not. I just tend to use it like this. Does that answer the question a bit? Or don't you? Okay. Assuming it answers the questions, I've deployed this Kubernetes demo with jobs, and if I check it in my Kubernetes environment, let's zoom it in a bit more. So I have this update last job run, it has been run, and I have this cron job, and it starts every 5 minutes. So when I look at this application, I see that the job has been run on a few minutes ago, and the cron job at this point gives an error. It's creating the container, and now it has run. So when I refresh it, my cron job random string is now updated. Okay, thanks Wesley. PHP has a plugin for support for Helm. It also offers auto-completion for the possible configuration of the various Kubernetes objects. So yeah, it makes it a lot easier to create your YAML files. So far, jobs and cron jobs. I still have like 10 minutes, so I want to show some fun stuff which you can do with Kubernetes and GitLab. What I want to show you is using review apps, because very often we work on an application and a product owner asks us to create a user story or to develop additional features which is written in the user story. And what would be great if that when I create a new feature branch and I am developing, I can show this feature branch to my product owner, and if he approves and he likes what has been developed and has tested it, then it will merge to the main branch and the main application. Normally on development teams you have this OTAP environment where you have this development on your local machine, maybe a test server, an acceptance server and a production server. In this case, we're aiming at continuous deployment. So the first step is creating an environment for every feature branch you're creating. So assume we have review apps. Assume we have this application I've been showing all along. And it has this Kubernetes Demo application. So welcome to the Kubernetes Demo. And I just commit this, commit and push. And it's going to build. So it has started a pipeline. There it is. And I just tell you something about this application. So it says hello name. So maybe my product owner wants me to change the title. So I normally in my workflow create a feature branch called feature Ode to the code. So and I just say hello Ode to the code. And I just commit this feature. Okay. So in the meantime, something is going to deploy. And what is going to happen? GitLab has an extra step, two extra steps. It has this build and deploy, which I've shown you. But now I've defined a review step and a cleanup step. So my deploy branch ignores my feature branches now. So I just say, you can do this, but not on feature branches. You could also say only master, so it will only deploy on master branch changes. And I have this deploy review stage, and this will only run when I commit to a feature branch. But the nice part about GitLab is you have this on stop mechanism, which runs whenever the branch is deleted or stopped. I will show you in a bit more. So it will run this when the feature branch has started, and my URL now is my app URL, and my app URL is defined as my feature branch. It gets a random hash of the feature branch. So let's see if it has been deployed. There it is. So it builds and it has deployed the review, but it hasn't done this yet. So in my resources, I have this feature Ode to the Code endpoint. I click it, Kubernetes Demo, Review, Feature, Ode, and some hash, .NET and .status panel. So it has automatically created a complete new environment based on my feature branch. It deploys it online in my Kubernetes system, and I can tell my product owner, hey, have a look at this URL. My product owner checks it and says to me, Aron, very good, I want this live. So I could just deploy it to live, but on a normal development flow, you would create a merge request. So I create a merge request where Ode to the Code should be merged into the review apps. Normally it would be master. I just compare it. Very nice code, new feature. I delete the source branch when the merge request is accepted. I of course check my changes. Okay, this is changed, so I submit it. And then my colleague comes along, not myself, but my colleague, and has a look at this, and he looks at the changes, and he says, well, this is very nice. Okay, you can merge it, or approve, and then I can merge it. So now this is merged. And when we look at the CI/CD, we see two things happening. First, the cleanup step of my previous deployment is run. So the stop review has been done. And what does this? It deletes the namespace. So when I look at my workload in Rancher, I only have my original production or acceptance environment running. So the review is not there anymore. It's gone. So the pods are destroyed. But my demo application has been updated with a hello name. So this is run. It should delete it. It should get a new pod, but it's updated there. And normally it would have my changes on the production environment or acceptance environment. Oh, it's still updating it. So I was too early. It's deploying it. Extra review apps deploy. Ah, there it is. So hopefully it will show, yeah, there it is. Sorry, I was too soon, but it will show hello Ode to the Code. So I've created a feature branch. I've deployed it to the Kubernetes cluster on a different URL. All the certificates are automatically created. I can show my product owner to deploy it, and it will run there. If I have 2 more minutes, I will have one more example, which I think personally is very nice, and it's the splitting of the apps, multiple containers under one URL structure. So I will just deploy it, so it will run in the meantime. When we develop applications, we often have multiple, we have a split backend and frontend. For a headless CMS, or you have this Angular application on the front end, a Laravel API on the back end, or a Symfony API on the back end. And it would be very nice to have this under one domain. But for cross-site course headers, it would be very nice to have my main application redirecting to Angular and my API to the API endpoint. So I have these two applications, my app and my API. And my API is nothing more than a web server which returns a JSON string, in this case Aron. And what I've did is I like to use Varnish as a caching mechanism. And I have this Varnish file which says, okay, if it's the app URL, go to the app port, and if it's the AP URL, go to the AP pod. And I define it like this. Everything on the /API route is redirected to the API, and everything else is redirected to the default. So when it's deployed, let's check it out. I hope it's done. It's almost done. So it's built my API. It has built my app. So this is an app image. it has built my varnish image, which can also be used to insanely fastly cache images, HTTP responses. And it's installing the pod now. So my time is up, but hopefully it will deploy soon. So in the meantime, I just finished my presentation because these are extra things. I had 2 more extras, but yeah, if you just want to see them, just contact me and I will gladly demonstrate them. And of course, some questions if there is time left. Just say it. So hopefully it will be deployed. It's deployed. So I have this workload, which is varnish. So this is my application. And when I go to API user, it will show my JSON. So this makes it very easy to have multiple pods under one domain structure, preventing cross-origin requests. And your API and your frontend will connect to it very nicely. So I use a lot of these tricks to structure applications. So far the talks. Thank you all for bearing with me, and I hope you enjoyed this talk about Kubernetes. If you have any questions, it's now the time.
Oh, thank you very much, Aron. I think if they have questions, we'll see them in the comments below. It usually takes a while, so like when you answer a question, they'll see it in a few seconds, so it takes a bit of time. But thank you very much for your Kubernetes talk.
Thank you. No problem.
If I got this correctly, so this means like you got libraries for your infrastructure as well. So you can just install a pod or a library for your SSL certificates for Let's Encrypt, things like that.
You define your whole infrastructure in a set of YAML files and then just run it.
Yeah, so like infrastructure as code kind of thing.
Yeah,
That's
exactly.
Really cool. Yeah, it was really fun. I also really like the part where you can just create a pull request and it'll just create a new URL for your product owner to access.
Yeah.
Should save you a lot of issues with it works on my machine kind of things.
That's true. Yeah.
Yeah. All right. Thank you very much. A small break for 5 minutes. And after that, we'll go on to the next talk by Ewout. Well, see you soon.
Thank you. Thank you all for watching.
Yes, no problem. So, welcome back, everyone. Hey, Ewout. Hope you're all.
Yeah. Hello there.
Hello. You ready to go?
Yeah, I think I am. Sure.
All right.
Let's hit it.
All right. Good luck and yeah, enjoy.
Thank you very much. Let's get the presentation to full screen. Where is it? This window needs to go. And yes, I do want to share my entire screen. You can see everything. Very nice. Right. Good evening, everybody. My name is Ewout. I'm one of the contributors for the PHPUnit open source project. And I want to show you some of the weirdness that is behind the scenes in, well, every library and every package you use. We just got a really nice demo of how to make sure your whole zoo of software behaves, gets automatically restarted, gets nicely boxed in. But that's just that's just part of the story, because inside software itself, there's also, of course, lots of flows and boundaries. And what better tool to use than something like a unit testing framework to have some fun with that? I work at a small Dutch consultancy called Ingress. We're home to another large open source project called PHP Documenter. And there's a lot of collaboration between me and my buddies there. And of course, PHPUnit itself is almost 20 years old, and I'm just a baby on the project. Sebastian Bergman, well, it's basically his thing. Other people have donated lots of code over the years, but it has lots of history, lots of social history, best practices from olden times you can still find in the code. Anybody who has upgraded, say, an old PHPUnit 5 install up to an 8 or a 9 these days, you just find so many things that used to be how we did it in the PHP community, and we no longer do. So it's an infrastructure project. Most developers just hope it works. Of course, we write tests because sometimes our boss tells us to, and sometimes we actually do TDD, and we use it to validate our software, which I hope this talk might inspire you a little bit to start doing more of that. Because PHPUnit can be used as a red pen, but it can also very much be used to gain a deeper understanding of what software actually does. So I'll just speed through the presentation a little bit. This is a presentation that's usually encapsulates workshops. And I'm going to break some of my own code, and we'll show you how strange larger libraries are behind the scenes, and how that actually affects your day-to-day work. I see so many job offers for full-stack engineers. I keep repeating this. I just don't get it. There are just so many layers in today's, well, shall we say, not even web applications anymore, but any application of any size that exists for longer than a few weeks with more than a few developers, you already have specialization. I'm not very good at front-end maintenance, never mind like from scratch front-end development. I'd love to know more about that, but it's just so complex. So there's many layers in larger projects, especially the web world, where I've been spending the last 20 years. It's lovely that it's almost small enough to understand everything, but then you think you understand it and you start looking a little bit deeper and you just run into lots of weirdness, which causes bugs, delays, etc. Yeah, what's on the screen right now? I think most people will recognize, in this case, it's Symfony. Any modern framework does something like this. I do not mean specifically the annotations, although that is quite frankly, 90% of it, because something like an annotation or an external YAML file or anything else, it's not code. So we just saw a lovely demo of infrastructure or by way of code, but YAML files, is it code? Is it configuration? That's, of course, it's a discussion. The question is, when does it happen in the sequence? What are the dependencies? What does it need, etc.? So something like this just works. If you take the Symfony Fast Track book, you just want to start with web development, you get examples like these. With a little bit of setup, thanks to Composer, thanks to Docker, this is really easy. But if you would spend some time on actually looking behind the scenes how this works, just put some debug breakpoints on this until you actually find where all this happens. First of all, you'll find out that it's not just one place. Even in the Symfony debugging console, if you look under the events, you can see how many events are triggered under the hood for just even a single web page like this, because this was from a test project that I used to get into Symfony 4 again. And it's really simple. It's just one page that will show me a student report card. There's just so much going on. Entities, all of a sudden I have a database. If I go to this URL, for some reason it works. The report with that ID has been retrieved and displayed. It's absolutely fantastic. Otherwise, we wouldn't get any large web app even going. There would be nothing to put into Kubernetes and to scale up. But this also causes bugs in larger, more complex projects when there's less time to debug. Unfortunately, generally, harder commercial deadlines, and there's a lot more magic going on. There's lots more Lego pieces, a bit of API there, a bit of library there. What does it do? Well, it kind of shows the output we want. But what are some of the problems? Well, I already used the word magic. On Reddit, programming forums, you'll see the term auto magic. And well, this is the code that comes with showing the report. That's already 5 use statements. And yeah, you already know this. Once you import something like the Symfony router or the Symfony controller, you get a lot for free, in quotes. There's just so much waking up, starting. I think it's really nice to just even look behind the scenes how all this works. That in 2020 PHP looks like this, and not like a souped up version of PHP 5, like this shit we had 10 years ago. So it's great, but it also causes problems when you actually need to work with high performance or more low level aspects of code. That's a bit of an edge case, but it does play a role in larger projects. But even day to day, just this confusion, how does this even work and how do I then make changes? For example, could I just retrieve this report based on the name? If it's unique enough? Actually, that works if you fiddle around a little bit and get your indexes right and everything. But I already said, if you fiddle around a little bit, this is what the Symfony manual themselves, what they say, not just in this particular spot, but in around other auto magic things. They do explicitly notice it, and they write this a few times. The magic is fine, but the magic is not free. There is no magic. What it is, it's a bunch of checks from Symfony. So the more you ask the framework to do, the more it will do, which consumes resources. So that's completely fine. On my laptop, I never bother with any kind of performance setup. If we need to deploy something on a live environment, except from the whole containerization and failover strategies, this magic can become very, very expensive once you get more visitors. For example, in the past, I worked for something like Marktplaats and Nationale Vacaturebank. I mean, these days, servers are more than fast enough to run even that on Symfony. But we had performance considerations. Like every sprint, there were a few tickets that just were too slow in reality on the hosting infra that we had. Why is this very slow? Why does this happen? A lot of stuff happens behind the scenes, whether it comes from config files. This is my personal pet peeve that you see on screen now, reflection. Reflection is fantastic. It's beautiful. It's also a Swiss Army knife that is just created purposely to help you hurt yourself. What it allows you to do is, from a running program, look at itself, which means that you can bypass lots and lots of checks that are in the language itself, or checks that are validations that are taken care of by the framework, or any framework you use. Like, you can instantiate something, configure it beautifully, take reflection, and just muck around in its private attributes, call private methods, whatever. But it's also what something like Symfony or Laravel or Doctrine or PHPUnit or all the code analysis tools, what we need to do, we need to inspect PHP pretty deeply. We use the parse tree of PHP files. We use reflection class. Basically, the units that you stick into PHPUnit, we take them back to the kitchen and we cook them a second time. Why is all this important? Maybe this is even a nicest. I love this slide. It's a beautiful picture. It's a table that's designed to create side effects. I've never, unfortunately, seen this thing in real life. I've seen other light and glass art that does pretty much the same. I live on the 10th floor with the sunlight right in my window. I would love to have something like this. But I want it in my living room. I do not want this in my software. It's great, but I want to know what's going on there. Most of the software that I work with deals with some kind of privacy-related data. Money, invoicing, it's a large part. This year I worked on the public transport system in the Netherlands. Those are all kind of systems where it's really not somewhere you want to invoice the wrong amount, or even just deduct the wrong amount of points from somebody's card, or just terminate an OVA card at the wrong date. So I also work a lot around software that is very unit testable most of the time. And PHPUnit is great for that, to just not just test, but actually validate that the core still does what you expect it to do. More complex scenarios like web testing, testing that would use a lot of infra setup. Is it still unit? Is it integration? I don't really care too much about these words. And one of the reasons for that is that PHPUnit, our own test suite, spent 5% of its time. I did some timings last month on the unit tests. And the other 95% of our own testing time in our GitHub pipeline is spent on integration testing. If you clone the project from GitHub, not just do a composer install, but if you clone it and you would look in the test directory, you would notice that we use a lot of PHPT tests, which are really like end-to-end tests. And this surprises a lot of people until you start looking what we use the end-to-end testing for. Unit testing is nice, but we only want to answer one question in the end. We don't want to test our software. We want to have it validated that it still works. So you run PHPUnit in full on a whole bunch of scenarios, because I can have a 100% line, branch, and whatever coverage on my unit test. But at the end of the day, I want to know if the thing starts, does what the customer expects, and then quits without leaving any trash behind. And that's what I want to validate. So for me, that's a bit of the difference between testing and validation. I love green tests, but it can also mean that you have assert true somewhere. something that I only saw this week again in a project that I was involved in consulting on. And so it just happened that like 2 out of the 10 or 20 tests that I had for this small project so far were just blanks. They're green. They'll show up in your Jenkins or Wrench or whatever dashboard, but it doesn't mean anything. So what is it? So what are we actually focusing on? On the complexity, and that's why we need help. The table is beautiful. I also really like this. This is a picture from a photonics lab in Leiden, Netherlands. And yeah, the things on the left, you just want your test framework to be, it needs to be very robust, and you need to be able to do instrumentation. And then the reporting is built in partially, but it's, of course, you can make much nicer reports when you put it in pipeline tools. So in the whole CI farms, the PHPUnit reporting is pretty much true or false, maybe a percentage, maybe some code coverage, but it can do a lot more if you use it on the command line. I don't think tonight I'll have much time to get into that, but maybe in 1 or 2 quick code demos I can show you. So this is a bit of a, I'll just run through this. This is what PHPUnit essentially does. And when I show this, people are kind of, for real? Yeah, this is pretty much the core loop. It takes an array of tests, and surprise, surprise, for each test, it gets run. It gathers a result, and in the end, it does a very fancy version of literally take the result object and dump it out. In case you do not believe me, I hope everybody can see my very low resolution screen. So, and I think it is, I always have to guess, it is this one. Yeah, so here we go. Thank you. You can take a screenshot now, and then you can write your own unit testing framework. The joke, of course, is that all the human tooling, like start and stop before tests, all the things that we've learned over the last 20 years are, above and below, and in all the different source files. PHPUnit can do a lot of things that you might not need for your project today, but that were community requests at some point, and with often very good reasoning behind them. There's also projects that have very good reasons to have PHPUnit extended, but because the core needs to be maintained pretty much for everybody, that's not something we can do. We need to spend our time on features that pretty much everybody might need, or now or in the near future. So that's why there's lots of plugins, extensions, wrappers around it. I'm currently talking to the Symfony Sensio Labs again about burning the PHPUnit Symfony bridge. Get some funding going for that. Something like Paratest is hopefully not needed anymore in a couple of months, just for the parallelization itself. Maybe for it's a beautiful reporting wrapper with extra options and fine tuning. But I'm currently working on reworking the deep internals of PHPUnit, the core iterators, and everything around that, the filters, to make sure that we can go parallel. Or even if it cannot be built into the core, that we have a better extension framework. There will be an events system later this year. So this is something that, I don't know if I put it in this presentation. Oops. This presentation or not. Can I have my StreamYards? Yeah, this is really annoying. It doesn't pick up the second Chrome. Oh my God. Hang on. It's because the presentation is full screen, I'm pretty sure. All right. Well, you know what? Because we're agile, we're just going to do it without the damn presentation. Why not? Boys and girls, never full screen your Chrome Google Sheet presentations to full screen when you use StreamYard. Something that I wanted to show you, what's basically the whole story behind it. This is a little demo file that I made. And this is about the core of this whole presentation. If you... I just heard another thing go away here. Yeah. So the main problem here is that if you have a testing function, you obviously do not want to write line after line after line of test data. I didn't really set it up well. Say you work for a fintech and you have a bunch of calculations that you want to do for your invoicing. So very often you have to calculate the VAT tax for different countries, for different styles, combinations, whatever. This is something that I keep running in time and time again. How do you do that? I think most people are familiar with the idea of a data provider. You have a test, and you run this test with a bunch of data. So instead of a whole bunch of... you know, like this, and then you have 1 and 2, and 1 plus minus 1, and stuff like that. And you have it with different VATs. I don't know. So you do not want a file that looks like... Oops. Come on. No. No. What the hell? I will... No, I will keep this... No. You know what? I'll just do it on my Mac. Right. Cool. There we go. So the thing that I wanted to show you, this looks like this is one thing, right? This is how you read this. You have a test, A, B, and a sum, and then I can make this list a lot longer. But for PHPUnit, this is not one test. Or is it? It's really a definition thing. And I really enjoy this problem with PHPUnit, so to speak, it's really about true or false. Lots of people really look at the red and green, whether something is wrong or not. But the only thing PHPUnit does is give you an answer to your question. And if that question is dumb, you will get a dumb answer. It's really garbage in, garbage out. So 100% coverage, I laugh at it. I mean, it's nice, but it's sort of your baseline. And because I always ask the question, what are your tests? What are you validating? Like, what do you want to do? Because this, behind the scenes, works very differently from having like a test 1 and 1 is 2 without the parameters, and I do it by hand, and I have a whole file full of these different tests. That internally, that looks different from have one test with multiple asserts, and it looks still different from having a single test with data provider. And when you draw this out on paper, of course, everybody will paint a lovely box with parameters and results. However, in real life, that's not how it works at all. And this comes down to the hidden complexity, that lovely little table that all of a sudden, because the light shines through, you get this explosion. Oh, that's inside. I can't really, ray trace it in my head, but I get where it's coming from. But in software, this hidden complexity can come out at the weirdest of times. And unfortunately, I didn't prepare a demo for that, mostly due to time constraints. But this little example can get very, very weird when the data provider up top here, and this one talks to a database. I think most people know this word static, right? This is not the same kind of animal in the zoo as the test itself. And PHPUnit currently views providers as configuration. As an end user, you do not notice this until you have a very complex application where basically you're talking to a test database, because spinning a test database Docker is much easier than mocking your data properly, or even mocking any kind of database stubs or other connection. So what do? Well, just quickly spin up MySQL Docker, put in the database skeleton with some test data, and just use the real stuff and just talk to test. And then I get questions. Why does the test not even run the same as the application? Well, because PHPUnit, it's a black box. It's not transparent. It hides most of the weirdness very, very well for your average 90% of the time use case. But in modern CI farms, it really becomes a problem. There's another little detail that I'm working on this winter on refactoring, because data providers are loaded as configuration. All data providers that are available will be started, will be read, and will be allocated resources before the first test is run. And this is one of these black box things where, yeah, you shouldn't worry about the implementation, but you do, because the upgrade that refactoring and upgrade that I'm working on now, it actually reduces cost for pipelines significantly, especially combined with some other ordering options that I built in, like you can run your tests in random order. Please try that at some point. It's hilarious. You'll be surprised how many test suites did not survive a reverse or random run. One of them was our own at PHPUnit. We didn't survive our own reverse run because we had a few tests that used global variables and environment variables and some other environment tests. And those tests had not been explicitly marked as sequence sensitive. Yes, you can declare dependencies in PHPUnit. It's pretty, well, this one is pretty much dependent on its data provider, but there's something like depends. And then you can write another test name. I can't type tonight. There's something else. And how do you? There we go. What PHPUnit will do is run test this or test something. I haven't renamed yet. And it will only do so if test something else has run first and has run non-failing. I wouldn't say completely successful. There are some other edge conditions where PHPUnit can decide, well, it didn't really fail, so I'll try. But it depends, protects you from like 99% of all the major use cases. We use it ourselves for exactly that type of reasons. When we want to declare a dependency, we do it with this. It also does dependency injection. That's a bit of a weird edge case that I never ever use, but as soon as you depend on another test, the result of that test will be inserted as the first parameter. Or from the front. So if you have multiple depends, in theory, it will insert multiple parameters, but I would actually have to check if that still works. Because this is one of those social technology things. Does the community need it? Like, I asked around, but I don't really know why the depends not just declares the dependency, but also injects. Does a dependency injection? It's kind of not useful sometimes, but it's more of this hidden complexity that you declare a dependency and all of a sudden you get a second parameter, or first one, you're like, what? Where does this come from? And it is in the manual, of course, but good luck finding out all the different capabilities of a test framework like this. Another thing that it's 10 past half. Yeah, so I think I can actually show you. Let's see if this still works. Yeah, so here we go. I just, the only thing I did, I made a special configuration in IntelliJ that it will run this file only and not start the rest of the test suite. So what do? What you see is instantiating tests. At this point, PHPUnit is specifically talking to JetBrains, PHP Storm, or IntelliJ. They use their own protocol. That's why there's no output here, but there's some output here. There's a special output renderer for JetBrains. So these windows look very nice. Another bit of complexity that doesn't happen automatically. All this is being developed on request. For example, the Team City output logger survives out of sequence output very, very well and fixes it in its own UI. We don't do it for it. It's another bit of complexity. So we're inside our data provider. On the right, stack frame, there's nothing going on except the usual. And on the left, we get to see where we are. Well, we are actually reading annotations. So this is another hint. It's not code that's being executed, those annotations. It is code that reads annotations and has its own parser. I'm very glad that PHP is moving towards actually incorporating such things into the language itself, so we can do much better analysis on it. But that aside, where are we? We are in main, so we are running. And because we're starting up, we're getting the test. We're adding test files. We're creating test suites. This is all internal tree structuring, reading the files, looking what's in. So we've opened the file at this point. We're adding test methods. Test something is being created. That's so lovely. Well, and we notice at some point that test something has a data provider. There's only one thing you can do: get the provided data. This is a static call already. It just, from this file, like the exact class and method, just run it as a unit. So it's properly sandboxed. But when you forget that it's properly sandboxed here and now at this point in the sequence, your database might not be there. That one temp file you want to create somewhere in your start is not there. So there's lots of little details that impact day-to-day life as a developer a lot. There's also lots of reasons behind the way it has been built like this. And that's also why the refactoring is going to be quite a bit of work, because we do have to support the old way of running it too. So we get a lot of new infrastructure that's much cleaner, much better validated, that can also run the old use case. So it's quite an operation. And well, maybe I can make it a New Year's present for us. So if we then hit play again, There we are inside our test. And ta-ta, A is 1, B is 1, and the sum is 2. First of all, thank you, JetBrains, and all the IDEs that came before it for giving me this type of tooling. Working on something like PHPUnit without good debugger? No, that's really not. That. You can do it. I do a lot of print R2, but this just gives you headaches. If you don't, this type of inspection, like right here, that is just amazing. And other tips and tricks. Do you guys know this one? The evaluate expression. It evaluates whatever PHP you type up here in the context of the stack frame. I have not looked in the Xdebug documentation or in other discussion online how this even works. Does it send it back to the running PHP runtime? I'm guessing yes, but this is amazing. You can do so much with it. Once you get used to this way of thinking, because it's not so much that this is super high-tech, but it is one of those things that works really well for humans. I can just start my program, I can put breakpoints in, and instead of just inspecting the breakpoints, I can actually have a bit of sandbox work and then press play. Also, once you get used and good with these buttons, like step over, step into, step out, run until cursor. I do a lot of my programming in this environment where I look at the program, how it runs, like it's my pet and I'm walking alongside it. So I'm not just looking for errors. A lot of the time I use this to just get a feel of how an application works. I just start hitting play and next until I kind of get it, and then I skip stuff. And I've let it run for a while. And where are we now? So we run deeper, we run even more. And at some point, we hit this data provider test suite, which is an internal object that you as a user didn't even order. Where does this even come from? But your code will run inside this sandbox that you never defined. The sequence test doesn't even use test suites. It extends the test case, but for some reason we're in here. That's weird. There's more run. How deep are we now? 7. And then finally we're going to go run bear, which still doesn't run the test. Run test does. And I just wanted to show you this little beauty. How do you run a test? Oh, first of all, you put it in the try catch, and and then you just use some ungodly reflection, and off you go. You press play. It's wonderful. It works. And then something like IntelliJ can give you this weird hybrid output where the test results here in the middle are gone, because this is in their own special format, so you can see them on the left. And you'll notice that it makes this little nice hierarchy, which we deliver to it, and it renders nicely. I really, really need this type of tooling. And, well, I can't see the camera myself, but like the paper posters on the right there, to just even wrap my head around what something like PHPUnit even does. It is near impossible to understand otherwise. I mean, of course, the basics are pretty simple, but it is all these details. How are data providers really loaded? And what do I have to hide from the user? Because we hide a lot of stuff and output that's just thrown around, and we check whether or not that's something that needs to be reported. Of course, if you throw out an exception, we'll trigger on it and give it nice output. But there's a lot of consideration for what is a defect. What is just a warning? How do we think about that? How do we communicate it to the user? How do we make this configurable? Like this whole bunch of like PHPUnit configuration flags that you never use or may not even know exists, like for execution ordering. Do you want to stop on warnings, yes or no? Why yes or why no in your project? Maybe your project has a lot of warnings because devs are lazy. Maybe your project has lots of test warnings because you have a hosting provider which you have no influence over. We try to stay away a bit from like really this is good or this is bad, while being super strict at the same time, which makes for fun discussions in Slack. Anyway, this is one of the most basic things that something like PHPUnit, but every other framework of any size has. As soon as you start juggling parameters, configuration, etc., and you see weird behavior, ask yourself, how does this flow work? Like, do I not maybe understand exactly what boundaries there are? Is data transformed between steps that I never even realized? Is something pre-calculated and then written to disk in a cache? Something which Symfony is really good at. And I think anybody who's worked with Symfony, and I guess Laravel over a couple of months, will have at some point just remove the whole cache directory just to be rid of weirdness. And this is normal. And it's completely expected, even if software gets as complicated as even something like a 20-year-old test framework that is made to be as simple as possible, because we don't want it to break. I don't want it to break because I use this thing myself every day for work. So it's not just hello from an open source project. This is my own eat your own dog food, literally. I look at this at least 5 days a week as a consumer too. And I love it to bits. It's so nice to write unit tests. Yeah, TDD is fantastic. So there's one thing that I wanted to show you because I have at least 10 minutes left, even though I still cannot see the StreamYard window. Yes, here it is. Oh, I did it wrong. I didn't do it wrong. I'll just show you both on one screen. This is what PHPUnit normally looks like. One test is one dot. You know, but we don't play Pac-Man anymore. That's for 80s arcades. And that's the kind of design this is. It's well, there's at least 4 colors. But it's 5. But above, that's where you notice, hey, this looks pretty different. And that is something that I see if this still works. So this is what PHPUnit actually looks like for me every day. It's colorful, and there are timings, and the tests are actually written down in normal English. It will highlight changes in directories. Oh, by the way, as I mentioned earlier, we have now arrived in integration testing land, which is roughly 95% of the actual test time that PHPUnit needs. The unit tests are long gone because, yeah, that's really simple. You have like a few parameters, and then you have an output that you check. Each of these tests will fire up a complete PHPUnit subprocess and set up the command line arguments and everything, and then basically does a full test run in very specific environments. And as you can see, there are so many use cases that you might never have seen in your own project. Well, a bunch of regression tests that I should get around at some point and fold into actually properly categorized tests, because many of these issues are completely, the solutions for these issues are completely baseline by now. They're not bug fixes anymore. Well, Isn't it lovely? So this is one of those edge cases. It's okay, but incomplete. Is this a failure run? It's a success run. I know this is a success run, but what does skipped also mean? Well, in this case, xdebug was not loaded. Yeah, is that a bug? I don't know. Might not be. I know in this case it's not, and let's have a quick gander. Yeah. So, PHP 8 specific tests. Sorry, not on this laptop. So, what you're looking at is the, I see a StreamYard alert. Is the, come on. Get this. Yeah. This is what TestDocs does. It will give you a nicer output, and how it doesn't work is very simple. There's a TestDocs annotation where you can actually put the parameters in. And it will nicely highlight them for you. This highlighting is also can be turned off for server or pipeline contexts. So this is what I've been focusing on the last 2.5 years at PHPUnit. Give you features that are really, really useful in your day-to-day work. Just make things less frustrating, like this command line test reporting. I've seen it in use more and more now. Using your running your test in random order, or just in reverse for shits and giggles. That's more and more of a common practice, and it is a great tool. I love it. It breaks my code every now and then again. So it's been declared a best practice by now. And other many things that are coming up. I don't have time at all to have a quick look at the wall. Later this year, PHPUnit will get a bunch of internal upgrades that you might never ever notice as a developer, but it will make it quite a bit faster, use much less memory, and at the end of the day, it will probably make your well, if you have an Atlassian Bitbucket license, for example, you might indeed see it in reduced costs. So, having said that, let's see if I can actually log in to StreamYard from another laptop, so I can at least look at the comments. So if there are any questions in the meantime, please do type them in the comments. And I hope you found this presentation slightly useful. What I said in the intro movie that was put on LinkedIn is there will be some useful stuff in there for not just for expert developers. Let's log into the broadcast studio. What's one of the, I think that using TestDocs day by day and having the TestDocs annotation is really useful. It helps me a lot. Because I didn't break this, but if you, whatever. I love errors like these. Good luck finding that one. But all of a sudden, your output will look like this while you notice the error. And you get lots of little nice details, like the dotted line on the left actually has meaning. You get lovely highlighting. And yes, I know about PEST. They stole it partially from me. No, but it's great. We need better output. Like the normal dot output that PHPUnit has had for years. I'd love to make something nicer for that too. Something with preferably very happy colors and animations and stuff. But it's these types of things that make my life a lot easier. So if you have any ideas that really would be a time saver, let me know. Because my to-do list is filled for the next 2 years, pretty much. But if there's a really nice idea, or a nice side project, you can always throw it in the bin or make a GitHub issue, and we might even get around to it. I see that there are no questions until now. That's good, because that means that everything is like super clear, and you're all already validating all your beautiful big applications. As this is one of I wouldn't say open source hobby. This is something that I do next to my work, so I have nothing to sell. Poke me on Twitter, GitHub, LinkedIn, whatever, if you want some more information about what I'm doing. I do have some open source hours for my work, thanks Ingewikkeld. So I can actually spend some time on your use cases or questions if you have them. And otherwise, I'll be over here in my corner refactoring stuff a couple hours a week. I cannot see how many participants there are, but if there's more than one, thank you for showing up. Yeah. And I had a good time. I really enjoy working on this. Even better if it completely fails and I have to improvise. So I hope it was, well, the screen is easy enough to read, I just see. So that worked out. That's it for me. Thanks.
Yeah, thank you very much as well for your your great presentation and your improv skills.
Quite a little bit. I still can't find the Chrome window on my Mac. Damn full screen apps.
That's gone.
It has two windows, and I should have known. But if you put Google presentations, if you put it full screen, it's a real tip for anybody out here who does tech talks and presentations. Full screening Chrome in general, it really hides focus in very weird ways. So I'll probably literally have to quit Chrome and start it again, and then kill the window.
Yeah, we have the same issue when we were using Zoom for meetings, and you full screen some presentation, it just goes whack. There's nothing you can do about it.
And, I mean, it's fine for tonight, and I can just giggle about it because I'm talking about breaking software. But imagine this happening and you're doing like a company product presentation. Boys and girls, watch out with your web tools, because sometimes it goes badly wrong.
Yeah, they probably didn't have tests for that.
We did a lovely audio-video test yesterday, and it worked like a charm. 15 minutes in.
Well, I'm glad it worked out anyway.
Yeah,
it was a really great presentation, and it's always nice to look at the inside of PHPUnit like that. Actually learned a few things. I didn't know about the test docs thingy. That just shows a lot more information.
Yeah, I made it on purpose. It already existed, and I spent it as a. That's why I mentioned if people have nice ideas for such improvements. I did the test docs coloring as a sort of a winter project. I was sitting at my kitchen table. It was dark outside, and I wanted a smaller refactoring just to have a bit of fun. So I had to play with ASCII colors. So that's also something that was in the sheet. Like, have fun with this. It's pick a project that you like and dick around with it. And if you don't want to do software in your evening hours, just don't. Leave it up to the nerds.
yeah. Either way is fine, right? And, I'm really glad you added the debugging part as well. I really like doing that. Like when you're using a package and it just throws an error and you have no idea what's going on, you can just add a breakpoint for that error and you can see why it's throwing.
Yeah, and those breakpoints. Okay, so here's the last thing that I can put on screen. Can you put my screen sharing in a little bit, like for 10 seconds? Because this is a tip for if like a very serious tip for PHP devs if you don't know that it exists. So everybody knows probably some variant of this, right? The breakpoints.
Yeah.
It probably works sort of the same in VS Code. Now, IntelliJ, so I do not know how extensive the VS Code plugins are these days. But you can enable it, you can suspend it, fine. You can put a condition in. And you can literally say, like, only break on this if A is smaller than 1. That already works. That's pretty cute. You see this link, more. holy crap, an advanced breakpoint screen. And once you start using stuff like evaluate and log, or just a breakpoint hit message, or put the stack trace in, or remove one's hit, lots of the usual print R cases, like print R where I am. Okay, just break, give me a stack trace. Or if you just want to log like what A is at that point, A is whatever. Yeah, this replaces a lot of the normal debugging use cases that I see my colleagues use every day. And IntelliJ is, and also PHP Storm is such a good tool once you get into the advanced options. I still only know a few of them, but I literally spend lots of my development time in the tools, not just in the edit window or in the debug or in the CLI. It can do a lot.
Yeah, it's really cool because like in the console and in your evaluate expression stuff, you also have auto completion, so everything just works.
It's once somebody just at a conference showed me hey, why don't you use this little evaluate expression? I was like,
yeah, first I was like mind blown.
Wait, but it works in C2. In the stack. How does it even work? It's amazing, and it has saved me a lot of time.
Yeah, same here. It's really great what you can do with that.
Yeah. So.
Well, thank you again. Yeah, have a great evening, and hope everyone's fine. Stay positive and test negative, that kind of thing.
Oh my God! Wow.
Yeah, hopefully talk to you later sometime.
I'm going to throw that one around one or two software testing slacks tomorrow. Jesus.
Yeah, I read it somewhere. It's great.
Oh, it's so corny. I love it.
Yeah.
Anyways, everybody, stay safe. And make sure your software wears a mask too, because if you get out of bounds, we'll find you.
All right. Well,
all right.
Great one. Bye.
Okay, this is for me. Bye-bye.
Bye-bye.